Welcome to solverfy.
Okay, in this problem, we are given the wave function of some free particle, and it's this decaying exponential where we don't know the values of big A and alpha, but we can assume that they're some positive number. And we are simply asked, as alpha increases, how does the uncertainty in the position change? And when alpha increases, how does the uncertainty in the momentum change? So this is really a Heisenberg uncertainty principle problem. Another thing we'll need to know is that to the position, the probability of locating a particle at a certain position is equal to the square of the wave function. Of course, you're doing a complex conjugate, and so this is an example of an observable where you would be determining the position of a particle given its wave function, for example. So perhaps the place to start would be to look at what this wave function looks like. So we can plot the wave function in x. Because it's a decaying exponential, it's going to look something like this. It's going to decay both ways. So it's some spiked distribution like this. And let's rewrite it up here. So just from our understanding of functions, we know that as alpha increases, we would expect this exponential to decay much faster, or rather decay in more for values of x. So that's what would happen, is this distribution rather would become more spiky, more localized. So this would have the effect, since the square of this wave function, multiplying it by its complex conjugate, that gives us the probability of locating a particle, position x. That's really telling us something about delta x. So to answer the first question, as alpha increases, we would expect delta x to decrease because this distribution is becoming more and more spiky, so the probability will be more densely packed towards the origin. So at this point, we can use the Heisenberg uncertainty principle to find how momentum changes, because it's not as obvious. So we can reorder this as we know that delta p, the momentum uncertainty, is always going to be greater than this minimum value, which is constant, Planck's constant, reduced Planck's constant h bar, divided by delta x. So if alpha increases, delta x goes down, which means this quantity, delta p, has to go up. And that's the answer. As alpha increases, delta x goes down, delta p goes up, using Heisenberg's uncertainty principle and the interpretation of the square of the wave function as the probability of locating a particle, its position. And that's it.